a lot more convenient.
Oh, you are good. Got plenty of sound. All right, let me know when you guys have your quizzes up.
All right, almost there. Group question.
Dalen. Dalen, you're funny.
What did he say?
He said, can we hear him all right? Which of course.
Oh. No, man, we haven't been able to hear Dalen's pretty voice for a while now.
His pretty voice. Yeah, poor Dalen. Okay.
Rip Dalen.
Oh. All right, I'm ready. Question 3.
I'm good.
Anyone want to start?
Yeah, I see that first question, so I'm going to pull up my software real quick. Okay, let's see. I'm just putting the numbers in real quick. 18, 52, 70, 17, 42, and 59. Okay. So question 3 says, out of 70 females in the sample, 52 can taste PTC. Out of 59 males in this sample, 42 can taste PTC. Use the data below. Let P1 be the proportion of females in the population that can taste PTC, and let P2 be the proportion of males in the population that can taste PTC. The research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? So use the data in the table to find P1. So P1 is going to be the proportion of females who can taste it. So that would be 52 divided by 70, which would be 0.743. That's what I got.
Yep, I agree.
That's what I got.
Okay.
Wait.
What? Sorry, go for it. I'll do 4. P hat 2 is 0.712. That's what I got.
That's what I got.
Okay.
Yep.
I'll jump on this one. Which set of the hypotheses is appropriate for addressing the research question? And it's going to be that first one. Actually, I believe it's the first one. That fourth one kind of threw me off.
Yeah, it's correct.
I thought it was the fourth one.
Let's see.
No, because you're still dealing with.
Because you're still trying to find out if the
population.
Yeah.
Yeah, I think it's the first one.
Okay.
The P hat is the sample, and the normal P is the population, and so you wouldn't want to do the sample compared to the population.
Yeah, you're trying to find out if one's the same or if it's different, right?
Mm-hmm.
Not if it's the other one's different.
Yeah.
Okay. So I'm going with that first one.
Yeah, after you guys explained it, first one, obviously.
Mm-hmm.
Well, I got admission here. I already did this quiz once, and that is correct.
Thanks, Scott.
Perfect.
Well, I kind of had to. Well, I won't go into all the details, but everything we've said so far is correct. I want to take question 6.
That's good to know.
That's the one I screwed up. Does anybody know what is the confidence interval?
The point estimate.
Yeah.
So is the point estimate, is that the statistic or whatever? So in this case, the z-score?
Point S. Yes, I think so.
Let's see.
Is a test statistic the same thing as a point estimate? Just out of all of them? I can't remember.
I thought a point estimate was. I thought P was a point estimate, not the P value, but the P and P hat. I thought.
Yeah, so this is like the crazy. Oh, just kidding. Lower bound equation for the confidence interval.
So the point estimate, would that be the the total sample proportion?
It's probably the z-score, but I don't know.
I can tell you it's not the p-value anyway.
Oh, it's not the p-value. It's probably the z-score then. I don't know why they would ask us something that we didn't.
I looked all through the lesson. I did a search for the term point estimate, and it's not in there.
Yeah. So is this a two proportion question?
Yes.
Yeah,
Because
okay.
it's not equal. It's two-tailed.
Yeah. So. Oh, what? I was thinking of the chi square on that first question. Oh well.
I think it's the z-score. The more I look at this.
What did you guys get for the z-score? I got 0.394.
That's what I got too.
Yeah.
Okay.
All right, you guys want to go with that?
Yeah. Let's do that.
Okay.
I don't have anything better to say.
You say 0.494 is what we're going with?
394, I believe.
Yeah. 3.9.
394. Yeah.
Okay, I'm trying to do the next one. I'm scared I'm gonna get it way off, but
So I found that using that that Excel spreadsheet that we were given, like, pretty much gives us the answers. So it's a lot easier than calculating and worrying about it, at least for
okay,
me.
that's a good idea.
Yeah, that's what I'm using.
Whose turn is it?
I think what Dan was taking this one.
I can do it, but I'm gonna. What's the name of that Excel sheet? I can't remember.
Categorical data analysis.
Yeah.
Okay. Oh, look at that. X1, N1. Oh, look at that. That's so nice. Why wasn't I using this before?
It's the best. It's the best.
Dude, I'm sorry, man.
No, I'm like pulling up this textbook.
All the
Writing out this gnarly thing in my book. Like, it works, but whatever. All right, so it looks like the margin of error.
You have to calculate the margin of error yourself, but it's really easy. You just do the
Upper minus lower divided by 2.
Okay.
Yeah.
Okay. So upper minus lower divided by 2.
Yeah.
I think it's the upper plus the lower divided by 2, and then you have to do the upper minus that. I'm pretty sure.
Oops. Oh, yeah. Okay, 1-2 portion. And then, let's see, where's the, check requirements greater than 10. Oh, it's already covered. Where's the upper and lower? Is that not on here? Do I have to calculate that out myself?
That's
It's
It's
in
at the bottom.
the
confidence
interval.
for P.
Yeah, confidence interval for P1 minus P2.
And then so you add those together and then divide that by 2.
Yeah, and you're in the 2 proportions tab, right?
Yeah.
Yeah.
So 0.031.
Okay, that's what I got too, and that was wrong.
I got 0.154.
That's what I got.
I
0.154.
got
After you divide it by 2, what do you do after that?
Well, you have to do like F21 minus E21 plus F21 divided by 2. And so
E21 minus E21 plus F21 divided by 2.
What
yeah,
did you get?
and so it's 0.154.
Yeah, so I got the same answer, and all I did was F21 minus E21 divided by 2.
And that's what I did.
Since it's negative, it's going to actually add it, right?
Yeah.
And then divide it by 2. Okay. Anyways,
That's what Dalen said.
yeah. Either
So
way,
are we?
I just did it a
Yeah.
little differently, sounds like.
0.154.
Yep.
Yeah.
Okay.
If you do E21 minus those 2 added, it's negative, which is a difference though. It's the same number, but just negative. I wonder if that makes a difference.
I'm pretty sure it does.
Probably has to be a positive number because it's actually, it's not a value, it's a difference.
Gotcha.
So that's always going to be positive.
Cool. All right, so then the lower bound is that negative 0.123.
0.128 and 0.185 for the upper.
Yep.
All right. And Dalen says 10 is fail to reject.
Which one?
The null.
The no.
Because the P score was like 0.693.
Yeah, the P score is higher than the significance level. So I would agree with that. Absolutely.
that's correct.
Okay. Scott, have you gone yet?
Number 11 is D. There's insufficient evidence to suggest true proportion of females who today's PTC is different from the true proportion of males.
Sounds good.
Yep.
Insufficient, and restate the alternative hypothesis.
Whoever said that last week was really helpful.
It was Devin, because he's awesome.
I think I finally got that kind of straight.
Devin, you're
Yeah.
awesome.
I just read it from the book, so the book's awesome.
We did something we didn't do.
From the what?
Oh, wait, what's that thing?
There's a book.
The book is money. It's so easy.
Okay, so I'll take 12 then. Yikes. Okay. For the next 9 questions, we will review the mortality rate and day of admission, heart attacks study with different data. Out of, holy crap, 118,519 who had a heart attack during a weekday, 16,713 had died. Out of 42,447 that had a heart attack on the weekend, 6,155 had died. Please use data presented here. All right. And it says let P1 be the proportion of patients who were admitted on a weekday and P2 that were admitted on a weekend who died. The research question for the study is given here. Is the proportion of patients who have a heart attack and are admitted into the hospital on a weekday who die less than the proportion of patients who have a heart attack and are admitted into the hospital on a weekend who die? Use a significance level of 0.05. Cool. So let me put this in really quick. Sample of 118,519. And then it wants to know if P1 is less than P2, right?
Yeah.
Okay, so the conditions for conducting a hypothesis test are satisfied, true or false. So that just means they have to be more than 5, right?
More than 10 for 2 proportions, but more than 5 for the chi-square.
Oh, you're right. So I would say these are definitely more than 10.
Yep.
So I would go true on that one.
Yeah, same.
I agree.
Yeah. Question 13, I have D. P1 is equal to P2 for the null, and then P1 is less than P2 for the alternative hypothesis.
Same.
I agree.
Great.
Okay, so I'll jump on 14. Use the data in the table to find P hat 1, and that would be 0.141.
Yeah.
In this Excel sheet, how did I know? I know about this before. This is so nice.
You were doing actual math? That's insane.
I was doing that.
Dude, seriously, the assignments for like the last 2 weeks have taken like 5 seconds because of that. Because
Yeah,
of
as
that.
long as you know how to use it, you're like golden.
Yeah, mine took a little
And
longer.
use the software. Super nice.
All right, Devin, I think this, or who is this? This one. Who's
I
this
can
for?
do it. Are we at the P2?
Yep.
He had 2.144.
I have 0.17.
Uh-oh. What did I do?
Uh-oh.
Mine gave me 145.
That's what I have, 145.
4, 5.
Let's all check our little numbers and make sure they're right.
So I did 6115 instead of 655. So I got 1.45 now is what I got. Sorry, guys.
Okay,
Wait, what was it?
0.145.
0.145 for P hat 2.
Yep.
Okay. Why is mine off?
Okay, who wants to grab this next one?
16, the z-score was negative 2.02.
That's what I got.
Yep.
Negative what?
2 point. Daylin, you want to get this one? This is the, would you shade to the left or the right? Left. Agreed.
Because
Okay.
the arrow is pointing left.
The arrow's pointing left and because it's negative. What is the p-value? P-value is 0.022.
Yep.
And then reject it because it's too short.
Can't ride the ride.
Yep.
Can't ride the ride, it's too short.
Okay, so which of the following best summarizes the conclusion of this test? So we rejected it, so it's going to be sufficient. Let's see.
And then it's the third one.
Is it?
Third one, yeah.
Okay, cool. Third one.
Okay,
Yep.
let me submit this. See how we did here.
The one I worry about is that point estimate that threw us off.
There's one that is wrong, and it is question 6.
The point estimate.
Point estimate.
No!
Okay, so what is the point estimate, for heaven's sake?
Well, I think the point estimate might be like so like the total proportion, so 94 divided by 129. So I think it might be 0.729. I'll try that. Let's see. Nope, it's not.
Okay,
That's going to drive me nuts.
Point estimate. And I even went to chapter 18 and I tried finding point estimate like anywhere in that.
yeah, me too. I went actually all the way back to the last exam and tried to find it, and it's mentioned several times, but not in a way that tells us what it is.
I went to the internet in general looking for that term, and it seems to be it's not always
Google
the same.
doesn't know.
Yeah, it's like it's on what kind of test or what kind of what kind of experiment you're running.
Oh, similar to the test statistic. So there has to be a chapter in which we learned how to determine what the test statistic or what the point estimate is. And I remember it in my head, but I don't remember what it was.
Yeah, I remember talking about it. Okay. So this is what I have. Point estimators, the statistics are called point estimators because they are just one number that is used to estimate a parameter. It gives one value as an estimate of a parameter. So maybe it's it's either the sample mean or the population mean, but I have that for a definition.
Well, in earlier,
Oh, because you have,
let's see. In chapter 17, I have, it might have been 16, but it says p hat is a point estimator for true proportion. Then it says p hat equals x divided by n. So that's why I thought it was maybe the total, but it wasn't.
and then I also have like when we find the confidence interval, it's a point estimate plus or minus the margin of error. So that number is also the point estimate.
So is the point estimate P1 minus P2?
Well, let's see. What percentage of accuracy? Let's see. 95% confidence interval. So 95 would be 1.96. Let me just try this. And I'll just try it. I'm not 100% sure, but submit. No, I don't think that's it. Dang it. Sorry, guys. But it's got to be the sample mean. Can someone try the, let's see, what would the sample mean be?
Maybe 94 to 129, maybe.
What would the sample mean be? Well, if you guys want, we can do the next quiz and then come back to it.
I may just accept the
Yeah, that's what I'm thinking too.
It is a 95%.
I mean, whatever. I do want to know what that is, but I don't know.
I think if we have a group of, what is this, 5 or 6 people, and none of us know it,
Yeah, we're not like duds. Or
you guys are.
I'd like to think that.
let me just try one thing.
I think it is a sample mean, honestly, but I should just figure out what the sample mean is. I've become dependent on the software.
I know, me too, right? I am on the internet, and it says, so 2 population samples, point estimate is the difference between 2 sample proportions. So P hat 1 minus
So it's 0.031.
That's the answer for sure.
I was going to try that one next. So that's P1 minus P2, like she was just saying.
And we didn't try that one yet?
Nuh-uh.
It was 0.031?
Yeah.
All right, well, I'll try my last attempt on it. 0.031. That's it.
Cool.
Nice.
Well, now we're never going to forget that.
P1, it's P1 minus P2 or P hat 1 minus.
It's P hat 1 minus P hat 2.
Okay.
That's what Chris.
Okay, I'm going to stop this video and send you guys a new link.
Okay, sounds good.